Now that we know about forces, for the next few days we're going to be learning about momentum. And to understand momentum, we need to remember Newton's third law. Newton's third law says, for every action, there is an equal and opposite reaction. The last time we took notes, we used the example of a space shuttle launch. There is the force of the fuel pushing down, and so the space shuttle launches into the atmosphere. Newton's third law is related to the study of momentum when you look at the momentum involved in the collision of two objects. For example, when you're playing pool and you make a shot or you go to break, the cue ball hits one of the others or more than one of the others, and they move in opposite directions. Every action has an equal and opposite reaction. Momentum, whose symbol is a lowercase p, is mass on the move. So we're looking at both how massive the object is and how fast it's traveling. Those two things together affect how it collides with other things and are known as momentum. So here is our definition of momentum. Momentum is a property a moving object has because of its mass and velocity. It's a property or a characteristic of that object that depends on both mass and velocity. And that leads us to our equation. Momentum is equal to the mass of the object times the velocity of the object. If we write that out in symbols, P stands for momentum, M stands for mass, and V stands for velocity. If we're going to have answers that are momentums, we need to know what units to put on the end of them. So let's look at what the units for momentum are. Momentum is mass times velocity. Mass, just like before, will be in kilograms, and velocity, just like before, will be in meters per second. When you put those two things together, you get the units for momentum. Kilogram meters per second. These are the units for momentum. And there's one more thing that we should add to our definition of momentum. We need to realize that objects that are not moving, objects whose velocity is zero, have no momentum. Let's think about a simple example. A semi and a car are traveling at the same velocity. Which one has a greater momentum? Did you guess? Probably so. But do you know why? The semi has more momentum because it has larger mass. One last thing. If we're going to look at collisions of objects, we need to know the law of conservation of momentum. So think about, what does the word conservation mean? To save something. So how does that relate to momentum? It almost sounds like Newton's first law again. The law of conservation of momentum says that the total momentum of a group of objects does not change unless an outside force acts on them. So if you have a group of objects, maybe two cars, and they collide with no other forces acting on them, the total momentum before the collision has to be equal to the total momentum after the collision. And that's it for today. Now you can work on your homework.